Hello students. So today I am doing class for class 12 science. The topic is the same topic that we were doing in the last online class. The topic is first order derivative. So this is your continuation class, right? So same exercise, exercise 3A. Each question carries 4 marks. Page number 293. So in the last class we did how to differentiate implicit function, explicit function and parametric function. So today we will do this question, find dy by dx when this question number 5.1 log of within bracket xy is equal to x square minus y square when x is equal to 1, y is equal to 1. So first of all you have to differentiate the given function. So let us write down the given function again. Therefore given log of xy is equal to x square minus y square. Okay. So now let us use the properties of logarithm on the left hand side, because you know the properties of logarithm now. That is, logarithm of the product of two numbers is equal to sum of their logarithms. That is, or this is log x plus log y is equal to x square minus y square. Okay. So now let us differentiate both the sides with respect to x to get the value for dy by dx. So in this case, since you have to get dy by dx, both x and y variables are here. That means x and y are the two variables. Okay. So let us differentiate it. Differentiating both the sides with respect to x. So what is the differentiation of log x with respect to x? 1 upon x plus, what is the differentiation of log y? Now we are differentiating it with respect to x. So first of all it is 1 upon y. Again you have to differentiate y with respect to x. That is dy by dx is equal to, now what is the differentiation of x square with respect to x? It is 2x minus, what is the differentiation of y square with respect to x? First of all it is 2y. Again you have to differentiate y with respect to x. That is dy by dx. Is that clear now? So now let us find out the value for dy by dx. That means you have to keep the term containing dy by dx on the left hand side and all other terms on the right hand side. So 1 upon y into dy by dx plus, so minus, it becomes plus on the left hand side. 2y dy by dx is equal to 2x. Now 1 upon x is taken to the right hand side, it becomes minus 1 upon x. Okay. So what is common on the left hand side? You can take common on the left hand side, or dy by dx within bracket, what do we get? 1 upon y plus 2y, which is equal to, on the right hand side, what's the LCM? The LCM is x. Okay. So x into 2x, it is 2x square, then minus 1. Right. So on the left hand side also within bracket, you can take the LCM here also. What's the LCM? It is y. So y is divided by y, that is 1, 1 ones are 1, plus 2y into y, that is 2y square. Right? So which is equal to 2x square minus 1 whole divided by x. So now you can find out the value for dy by dx. So what is the value for dy by dx now? So dy by dx is equal to, now cross multiply by y here. So y into 2x square minus 1, then cross multiply 1 plus 2y square by x. That means x within bracket, it is 1 plus 2y square. Okay. But this is not your answer, because you have to get the value for dy by dx here when x is equal to 1, y is equal to 1. Now you have to put the values of x and y. That is, x is equal to 1 and y is equal to 1, right? So putting putting x is equal to 1, y is equal to 1, right? So therefore dy by dx is equal to, now what is the value for y? It is 1 within bracket 2 into what is x square? 1 square minus 1 whole divided by x is 1 within bracket 1 plus 2 into 1 square. So let's simplify it. Or dy by dx is equal to, this is 2 ones are 2 minus 1, that is 1 divided by 1 plus 2 ones are 2, 1 square is 1, 2 ones are 2, 2 plus 1 is 3. So 3 ones are 3. So what is the final answer? The final answer is dy by dx is equal to 1 upon 3. So this is the answer. So you can copy it. We'll do the next question now. So now again you have to find out dy by dx when, this is question number 5.3, x to the power y into y to the power x is equal to 1. So here also you cannot differentiate it directly because x to the power y, in x to the power y both the base and the powers are the variables. You cannot differentiate it directly, you have to take log here. So you can take log on both the sides. So write down taking log on both the sides. So taking log on both the sides, what do we get? Log of xy into y to the x to the power y into y to the power x is equal to log 1. And you know log 1 is always 0. If the base is not written out there, the base is e, right? So it is understood that the base out here is e. So what is log of AB? This is log x to the power y plus log y to the power x is equal to log 1 is always 0. Its value is 0. Or now this power becomes the coefficient y log x because this is from the properties of logarithm, plus x comes in the front, x log y is equal to 0. Now you can get the value for dy by dx. Since you have to get the value for dy by dx, you have to differentiate both the sides with respect to x. So in this case, both x and y are the variables. So right now differentiating both the sides with respect to x, right? So y log x is there. You have to use the UV rule, isn't it? So therefore you can write or also. So differentiate y into log x. So you have to use UV rule. So y is kept as it is. What is the differentiation of log x? 1 upon x. Next, plus. Now log x is kept as it is into, what is the differentiation of y with respect to x? It is dy by dx. Right? Next, plus. Again, x into log y is there. Right? So let us keep x as it is into, what is the differentiation of log y with respect to x? It is 1 upon y. But we are differentiating it with respect to x, so it is dy by dx. So x is kept same out there. Log y, what is the differentiation of log y? It is 1 upon y into dy by dx because we are differentiating with respect to x. Okay? Plus, now log y is kept as it is. Log y is kept as it is. Take the differentiation of x with respect to x. That is, what is dy by dx of x? It is always 1. So which is equal to dy by dx of 0 is always 0. That is constant. Okay. Now let us find out the value for dy by dx. Now you have to solve for dy by dx. Keep the terms containing dy by dx on the left hand side. All of the terms to the right hand side. So or now here from second and third, what is common? Dy by dx taken common. So within bracket, what do we have? It is log x plus x upon y, which is equal to, now we have to take that terms which are free from dy by dx to the right hand side. So it becomes minus y by x minus log y. Is that clear to all of you? So Now let us simplify it. Let us take the LCM within bracket here. So what's the LCM? It is y. So it is y log x plus x bracket closed is equal to, here minus is taken common, so within bracket, what's the LCM? The LCM is x, okay? So this x is divided by x, that is 1. 1 into y is y. So minus is taken common here. Minus into minus, this is plus. Now below log y there is 1. So x is divided by 1, that is x. So x into log y. So it is x into log y. Now what is the value for dy by dx? So dy by dx is equal to, now this fraction should be taken to the right hand side, or you can do cross multiplication also here. So what is the final answer? Minus y, y le cross multiply gane. So cross multiply by y here, y into y plus x log y, this whole divided by, now cross multiply x by this numerator, that is x within bracket y log x plus x. Okay, so this is the final answer. So this is your final answer. So I think you have understood it. So we can copy it. We'll do the next question. So now we'll do the next question. Here also you have to find out dy by dx when, this is question number 5.4. Cos x whole to the power y is equal to sin y whole to the power x. Here also the variables are x and y, but in this case both the base and the powers are the variables. So here also you cannot differentiate it directly. So these powers should come in the front. These powers should be taken to the front. That means you have to take log on both the sides. So let us take log on both the sides, right? So taking log on both the sides. Taking log on both the sides. What do we get? Log, it is cos x whole to the power y is equal to log sin y whole to the power x, right? So now because of that log, you know properties of logarithm, power becomes the coefficient in both the sides, okay? So it is y log of cos x is equal to x log of sin y. So is that understood now? So now you can differentiate both the sides with respect to x. So let us write here, differentiating both the sides with respect to x, okay? So or, now you can use your uv rule. Y is u, log of cos x is v. So what is uv rule here? Y is kept as it is. Now differentiate log of cos x with respect to x. You know that how to differentiate it. So it is 1 upon x means here 1 upon cos x into, again differentiate cos x minus sin x, right? Then again plus log of cos x remains same. Now you have to differentiate this function y with respect to x, that is dy by dx. Dy by dx, right? So which is equal to, now on the right hand side also there are product of two functions, x into log of sin y. X is u, log of sin y is v. So here also you can use uv rule for differentiating, right? So x is kept as it is. Now differentiate log of sin y. It is just like a log x. 1 upon x. 1 upon x here is 1 upon sin y into, again differentiate sin y with respect to x. It is, first of all it is cos y. Now y is taken as x here. So this should be differentiated with respect to x. So it is dy by dx. So this is your dy by dx. Is it understood now? So here x is kept as it is. Log of sin y, differentiation is, first of all it is 1 by sin y because it is in the form log x. Log x को differentiation कर दियो 1 upon x. So it is 1 upon sin y into, again differentiate sin y with respect to x. It is, first of all it is cos y. Again, you have to differentiate the term which is assumed as x. That is, y should be differentiated with respect to x. That is dy by dx. Okay? Plus, again you have to differentiate x with respect to x, keeping log of sine y same. That is, log of sine y is kept as it is into, what is the differentiation of x with respect to x? That is 1. Is that clear? So this is your differentiation. Now let us simplify it. Now in the next step, or now this is, let's simplify it, minus y into what is sin x by cos x? It is tan x. Next, plus log of cos x into dy by dx, okay, is equal to x into, what is cos y by sin y? Cot y. It is cot y into dy by dx, right? Then what is the last one? It is plus log of sin y. Plus log of sin y. Now is it understood now? So now you have to get the value for dy by dx. Now you keep the terms containing dy by dx on the left hand side and all other terms which are free from dy by dx on the right hand side. This is just like solving for x, but in this case we are solving for dy by dx. So, or log of cos x into dy by dx, then x cot y dy by dx, take to the left hand side, becomes minus x cot y into dy by dx, which is equal to, so what will you write on the right hand side? So write on the remaining terms. What are the remaining terms? First it is log of sin y, then minus y tan x, take it to the right hand side, becomes plus y tan x. Is it understood? Now let us take common from the left hand side. What is common here? It is dy by dx. Now within second bracket it is log of cos x minus x cot y. So here dy by dx is taken common and right hand side remains same, that is log of sin y plus y tan x, right? So, or what is the value for dy by dx now? So dy by dx is equal to, that is, what is right hand side here? Log of sin y plus y tan x, this whole divided by, now since this is dy by dx into is there, this expression, when this expression goes to the right hand side, you should write it in the denominator, that is log of cos x minus x cot y. So this is your final answer. So this is the answer. Understood? So you can copy it. We'll do the next question now. So now we'll do the next question, that is problem number 5. Find dy by dx when e to the power xy minus 4xy is equal to 4. So this question is from HS question paper also. This type of problem you may get in higher secondary question papers also. Okay. So in this case you cannot take log on both the sides because this e is a constant and xy is a variable. You can write here e to the power x. E to the power x as a function in this case, so to differentiate it, isn't it? So directly you can differentiate it. So write down differentiating both the sides with respect to x, okay? Or what is d by dx of e to the power xy? You have to take it as e to the power x. Here xy is taken as x. What is the differentiation of e to the power x? It is e to the power x, but here it is e to the power xy into, again you have to differentiate the term which is assumed as x. Which function is taken as x here? It is xy. Again you have to differentiate it. That means if you differentiate xy, you have to use UV rule. So x is kept as it is into dy by dx, right? Plus y is kept as it is into what is dy by dx of x? 1. So if it is 1, no need of writing it because y into 1 is always y. So second bracket is closed. So minus 4 within second bracket, 4 is constant. So minus 4 is there. So within second bracket you have to use UV rule for xy. So you know UV rule, right? So just now we applied here x into dy by dx plus y into 1. Differentiation of x is 1 with respect to x. So no need of writing 1 out there because y into 1 is always y. So second bracket is closed is equal to what is dy by dx of 4? It is 0. So let us get the value for dy by dx here. X into e to the power xy into dy by dx plus y into e to the power xy. So it is multiplied minus 4x into dy by dx minus into plus minus 4y which is equal to 0. Okay. Now we have to get the value for dy by dx. So keep the terms containing dy by dx on the left hand side and all other terms which are free from dy by dx, take them to the right hand side. So now from first term and third term there is common. What is common? X into dy by dx is taken common. So within bracket what do we get? E to the power xy minus 4. Now is equal to. Now this second and fourth term they are taken to the right hand side. So becomes minus y e to the power xy plus 4y. Is it clear now? So let us simplify it. So or x into dy by dx within bracket e to the power xy minus 4 e to the power xy minus 4 is equal to, so on the right hand side you can take minus y as common. So minus y within bracket, what do we get? Minus y is taken common here. So e to the power xy minus 4. Is that clear to all of you? So what is the value for dy by dx? Dy by dx, now into is there. So write on right hand side in the numerator y into e to the power xy minus 4. When this, that is the term x within bracket e to the power xy minus 4 goes to the right hand side. So you should write it in the denominator, that is whole divided by x into e to the power xy minus 4. Right? So you can cancel here. This is 1. Or what is the final answer? So dy by dx is equal to, what is the answer here? It is minus y by x, which is in the simplified form. So this is the answer. So this is very, very important question. Okay. So you can copy it. We'll do the next question now. So now we'll do the next question. That is question number 5-6. Find dy by dx when x to the power m into y to the power n is equal to x plus y whole to the power m plus n. So actually this question is not given in the book. The question given in the book was this one. That is x cube y to the power 4 is equal to x plus y whole to the power 7. Find dy by dx. So this will be a homework. Okay. I'll do this question here. You have to find out dy by dx for this one. I'll do this question here in this online class. So this will be your homework. Okay. Actually these two questions are similar. Like x to the power n is there into y to the power n is equal to x plus y whole to the power n plus n. Similarly here also x cube into y to the power 4 is equal to x plus y whole to the power. Actually it is 3 plus 4 which is equal to 7. So that is your homework. Okay. So let's do this question. So in this case also, if you use logarithm, you can get the answer in the simplified form. Let us take log on both the sides. Actually, no need of taking log on both the sides in this case because base is the variable but power is a constant. So directly you can differentiate it also. But it will be easier for you if you take log on both the sides. If you use properties of logarithm, you can get the simplified answer out here. Okay, so let us take log on both the sides. So similarly you can do that problem, right? So that is your homework. So taking log on both the sides. Taking log on both the sides, what do we get? Therefore, log within bracket x to the power n into y to the power n is equal to log x plus y whole to the power n plus n, right? So now you can use the properties of logarithm here, or so now it is just like your log of AB form. A here is x to the power n, b is y to the power n. So log a plus log b, so it is log x to the power n plus log y to the power n is equal to. Now in this case, this is just like your log x to the power n. Now power n becomes a coefficient. Here the power n plus n becomes a coefficient. That is n plus n into log of x plus y. Okay. Now next, or here also this power n becomes a coefficient because of this log. That is the properties of logarithm, m log x plus, now this is n log y is equal to, this is n plus n into log of x plus y. So is that clear to all of you? But you cannot simplify this log of x plus y, okay? So you have to keep it as it is. Log of x plus y cannot be simplified further, okay? Now this is the simplified form. Now we can differentiate both the sides with respect to x. So right here, differentiating both the sides, with respect to x. Let us differentiate it now. So next, or now differentiate m log x. M is constant, it is kept as it is. What is the differentiation of log x? 1 upon x, right? Plus n is constant here. N into what is log y? Differentiation with respect to x. 1 by y into dy by dx. You know that. 1 by y into dy by dx, which is equal to. Now on the right hand side, which is constant here? M plus n. It is kept as it is. Remains same. N plus n into, now differentiate log of x plus y. You should take it as log x, right? What is the differentiation of log x? 1 upon x, but here it is 1 upon x plus y. Which function is taken as x? X plus y. Again you have to differentiate that term which is assumed as x. So in this case, x plus y was assumed as x. You have to differentiate that term x plus y with respect to x. That is dy dx of, this is your x plus y. Is that clear to all of you? So let us simplify it, or m upon x plus n upon y into dy by dx is equal to, what is there on the right hand side? It is n plus n into 1 is n plus n divided by x plus y, and then into within bracket. What do we get? Now we have to differentiate x plus y with respect to x. That is, what is dy by dx of x? 1 plus, again what is dy by dx of y? It is dy by dx. So understood this one? Okay, now let's simplify it now. So you have to solve for dy by dx. It is just like solving for x, isn't it? So you have to solve for dy by dx in this case. Or, so let us simplify it. M by x plus n by y into dy by dx, which is equal to, so on the right hand side you have to multiply 1 plus dy by dx by n plus n divided by x plus y, right? So it is n plus n divided by x plus y plus, next it is n plus n divided by x plus y into that is your dy by dx. So it is multiplied, right? So now next step, in the next step again you have to solve for dy by dx. Keep the terms containing dy by dx on the left hand side and all of the terms which are free from dy by dx on the right hand side. Okay, so or this is n by y into dy by dx, then take this term to the left hand side, that is minus, it becomes minus m plus n divided by x plus y into dy by dx is equal to. Now what is there on the right hand side? It is m plus n divided by x plus y. Then this m by x is taken to the right hand side. That is minus m by x. Is that clear? So now let us get the value for dy by dx. Or what is common on the left hand side? It is dy by dx. So within bracket, what do we get? It is n by y minus m plus n divided by x plus y is equal to. Now on the right hand side, you can take the LCM. What is the LCM for x plus y and x? That is x into x plus y is the LCM. Now this LCM is divided by this. This x into x plus y LCM is divided by this factor x plus y. So x plus y gets cancelled, so it remains x. So you should multiply x by the numerator, that is m plus n, right? Then minus sign is there. Now this LCM, x into x plus y is divided by x. X gets cancelled, you will get x plus y. So that x plus y should be multiplied by m. So m into what? This is x plus y. Is it clear? So on the left hand side also dy by dx, here also take the LCM. Here LCM is y into x plus y, right? Now this LCM is divided by this factor y. Y gets cancelled, you will get x plus y. Now this x plus y should be multiplied by the numerator, that is n into x plus y. Then comes minus. Again this factor, this LCM is divided by the factor x plus y. So x plus y gets cancelled, you get only y. So y should be multiplied by m plus n. Y into m plus n. So second bracket is closed. Is that clear? So next is equal to, now here you can multiply it, mx plus nx, right? Then minus mx, minus into plus minus my. Clear? Whole divided by, in the denominator, x into x plus y. So I think you have understood it. So here you can cancel this mx gets cancels. You can cancel them. Or dy by dx. Now within second bracket, now multiply here, multiply the numerator n into x, nx plus ny minus my minus ny. Divided by y into x plus y. Second bracket is closed, which is equal to, now on the right hand side it is nx minus my whole divided by x into x plus y. Clear? Next, here you can cancel ny gets cancels. Or what is the value for dy by dx here? It is in the numerator we have nx minus my divided by y into x plus y. Second bracket is closed, is equal to nx minus my divided by x into x plus y. Is that clear to all of you? Now again you can simplify it further. Now let us simplify it further. So from both the sides you can cancel the common term in the numerator as well as in the denominator, or you may cross multiply it. Let us do cross multiplication. Or dy by dx is equal to, so now let us cross multiply. So what is the value for dy by dx? Cross multiply by y into x plus y into what? Nx minus my. It is nx minus my, this whole divided by, in the denominator you can write this x into x plus y is cross multiplied by this numerator on the left hand side. Okay, so x into x plus y, x into x plus y into nx minus my. It is nx minus my. Is that understood? So I think I've understood it. So here you can cancel the common factors, x plus y 1 1, nx minus y, that is also 1 1. So what is the final answer here? So or dy by dx is equal to, what is the answer in this case? It is y by x. So this is the final answer. That is dy by dx is equal to y by x. So similarly you can do this problem. Now this problem is given in the book. Its answer should be this one only, that is y by x. You will get y by x, that is the value for dy by dx. Okay, so let's do the next question now. So now we'll do the next question, that is find number 7. Here also find dy by dx when xy is equal to tan of x plus y. So don't use the formula on the right hand side, tan of x plus y. This is from common angle, isn't it? Tan of a plus b, tan a plus tan b divided by 1 minus tan a tan b. If you use that formula, it will be complicated, right? So let us differentiate it directly, okay, without using the formula of tan of x plus y. So what we will do here is, you have to find out dy by dx. So differentiating both the sides with respect to x. So therefore, on the left hand side xy is there, you can use the UV rule, right? So x into dy by dx plus y into 1. That is, differentiation of x is always 1. So you don't have to write 1 here because y 1s are y. Is equal to, now on the right hand side, tan of x plus y is there. How will you differentiate it? You have to take it as tan x, and x plus y is assumed as x. So what is the differentiation of tan x? It is sec square, but what is x here? X plus y. Again you have to differentiate the term which is assumed as x. That is, x plus y was assumed as x. And also in this case you have to differentiate the term which is assumed as x. That is, you have to differentiate x plus y with respect to x. That is dy by dx of x plus y. Is that clear to all of you? So now, or x into dy by dx plus y is equal to sec square within bracket x plus y into within third bracket. Now differentiate x plus y with respect to x. First of all, what is dy by dx of x? 1 plus, again what is dy by dx of y? It is dy by dx. So here third bracket is closed. Clear? Now let's simplify it. You have to get the value of dy by dx. Simplify right hand side now. You can multiply them. Dy by dx plus y is equal to, here it is sec square x plus y into 1 is sec square x plus y plus sec square, this is x plus y into this is your dy by dx. Is that clear to all of you? So I think I have understood it. So now get the value for dy by dx. Let us get the value for dy by dx now, right? So, or x into dy by dx. Now keep the terms containing dy by dx on the left hand side. So you have to take this term, that is sec square x plus y dy by dx, on the left hand side. So it becomes minus sec square x plus y into dy by dx is equal to. So on the right hand side, what do we get? It is sec square x plus y, and this plus y is taken to the right hand side. So it becomes minus y, right? So you can take common on the left hand side. What is common on the left hand side? It is dy by dx. So within second bracket x minus sec square within bracket x plus y, which is equal to, on the right hand side it is kept same, that is sec square x plus y minus y. Is it clear now? So what is the value for dy by dx here? Or, so dy by dx is equal to sec square x plus y minus y whole divided by x minus sec square x plus y. Is that clear? So this may be the answer, or you can simplify it further. You can keep the answer as it is. This may be the answer, but you can simplify it further, because in the question what is given there? The question was xy is equal to tan of x plus y. This was differentiated, isn't it? So this is given actually in the question. In the question it was given, that is the, what is the value for tan of x plus y? It is xy, right? Now this sec square x plus y is there. You can use the formula in this case. That is, you know, sec square theta is equal to 1 plus tan square theta. Similarly, what is sec square x plus y? It is 1 plus tan square x plus y. So after using this formula, you can put the value for tan of within bracket x plus y, which is equal to xy, right? So or dy by dx. So or dy by dx is equal to, what is sec square x plus y? It is 1 plus tan square within bracket x plus y. Then write down minus y. This whole divided by x minus, so within second bracket. Let us write down the formula for sec square x plus y within second bracket, because there is minus sign out here. That's why we are writing the formula within second bracket. So it is 1 plus tan square within bracket x plus y. So you know that sec square theta is equal to 1 plus tan square theta. Okay, so or now it is dy by dx is equal to, now it is 1 plus, actually what was the value for tan of x plus y from the question? It is xy. Tan of x plus y is equal to xy, right? So xy whole square. So this is xy whole square minus y, right? Whole divided by, so x minus, you can open this bracket, minus in minus 1 minus into plus minus, and what is tan of x plus y? It is xy. You can write here xy whole square. Okay, now let's simplify it further. Or dy by dx is equal to, what is it? 1 plus, what is xy whole square? It is x square y square. Then write down minus y. This whole divided by x minus 1 minus, what is xy whole square? It is x square y square. So this is the final answer. So I think you have understood it. So you can copy it. We'll do the next question now. So now we'll do the next question, that is find number 8. Find dy by dx when xy plus 1 is equal to cos of xy. But in this case, you have to get the value for dy by dx when x is equal to pi by 2, y is equal to 0. So first of all, you should get the value for dy by dx always, okay? You should get dy by dx in terms of x and y, right? So let us differentiate it, given function. So again, write down given xy plus 1 is equal to cos of xy, right? So directly you can differentiate it, differentiating both the sides with respect to x, right? So now what is d by dx of xy? UV rule. So x into differentiate y with respect to x, dy by dx plus, now y is kept as it is. Take the differentiation of x with respect to x, that is always 1. And you don't have to write 1 because y ones are y. And plus 1 it is 0. Don't have to write it. Is equal to, how will you differentiate cos of xy? You should take it as cos x form. What is the differentiation of cos x? Minus sin x. But what is sin x here? It is xy. Now again you have to differentiate the term which is assumed as x. So in this case xy was assumed as x. You have to differentiate that xy. So into d by dx of xy. Is it clear? So or x into dy by dx plus y is equal to minus sine of xy. Now within bracket, what is d by dx of xy? UV rule. So x into dy by dx plus y into, what is the differentiation of x with respect to x? That is always 1, so it is only y. So let's simplify it. Keep the left hand side as it is. X dy by dx plus y is equal to, now simplify the right hand side. So what do we get? Minus x sine of xy into dy by dx, right? So minus into plus, minus, then y sine of within bracket, it is xy. Is it clear now? Now you should get the value for dy by dx. Okay. Now keep the terms containing dy by dx on the left hand side and all of the terms on the right hand side. So x into dy by dx. Then this minus x sine of xy divided by dx goes to the left hand side. It becomes plus sine of xy into dy by dx. Plus x sine of xy into dy by dx is equal to minus y sine of xy, which is on the right hand side, minus y sine of xy. Now this plus y is taken to the right hand side. It becomes minus y. So it is minus y, right? So let's take common out here. What is common here? X into dy by dx. So within bracket, what do we get? It is 1 plus sine of xy, bracket closed, is equal to, on the right hand side, what is common there? It is minus y. So within bracket, what do we get? It is sine of xy plus 1. Is it clear? So now you can cancel the common term on both the sides, which are in the numerator. So these are the common term, you can cancel them, that it is divided, that is 1. So or now x into dy by dx is equal to minus y. So what is the value for dy by dx? So dy by dx is equal to minus y by x. Understood? So what is the value for dy by dx? It is minus y upon x. So now, this is not your answer because the values are given here. The values given here is when x is equal to pi by 2, y is equal to 0. So here, we have to put when x is equal to pi by 2, then y is equal to 0. Now what is dy by dx here? So dy by dx is equal to minus, what is the value for y? 0 divided by what is x? It is pi by 2. Or, so dy by dx is equal to, what is the answer? 0 divided by number is always 0, and you don't write minus in front of 0 because 0 is neither positive nor negative, it is neutral. So what is the value for dy by dx? It is 0. So the value for dy by dx is equal to 0. That is the final answer. So we can copy it. We'll do the next question now. So now we'll do the next question, that is find number 10. Find dy by dx when log of xy is equal to e to the power, if the power is x plus y, then plus 2 is a constant. So you can differentiate it directly with respect to x. So write down differentiating both the sides with respect to x, right? So, or you can use the properties of logarithm out there also, that is log x plus log y also, or you may differentiate it directly. So it is in the form log x. What is the differentiation of log x? 1 upon x. But here it is 1 upon xy into, again you have to differentiate the term which is assumed as x. So in this case xy is assumed as x. You have to differentiate it again. That means you have to differentiate xy. So it is UV rule, use UV rule, x into dy by dx plus y into d by dx of x is always 1. So here second bracket is closed. Is equal to, now differentiate the right hand side. So how do you differentiate e to the power x plus y? You used to take it as e to the power x. What is the differentiation of e to the power x? E to the power x, that is e to the power x plus y. Again differentiate the term which is assumed as x. So in this case x plus y was assumed as x. So you have to differentiate x plus y. So into d by dx of x plus y, right? And plus 2, what is the differentiation of d by, what is the differentiation of 2 with respect to x? That is always 0, right? So this is the differentiation. Now let us simplify it. You can multiply them, 1 upon xy into x divided by dx, that is x's cancels, 1 upon y into dy by dx plus 1 upon xy into y gets cancelled, we get 1 upon x. So is it clear now? So which is equal to, on the right hand side, e to the power x plus y, and within bracket, what is d by dx of x plus y? First of all, it is dy by dx of x is always 1 plus dy by dx of y is dy by dx, right? So now, or 1 upon y into dy by dx plus 1 upon x is equal to, now multiply the right hand side here, e to the power x plus y into 1 e to the power x plus y plus e to the power x plus y into dy by dx. So we got this relation. So now let us find out the value for dy by dx. Now you can write down the terms containing dy by dx on the left hand side. So what do we get? 1 upon y into dy by dx, then plus e to the power x plus y into dy by dx. Take to the left hand side. So it is minus e to the power x plus y into dy by dx, right? So the terms which do not contain dy by dx, take them to the right hand side. So that is e to the power x plus y, then minus 1 upon x. Is it clear now? So let us simplify it. Or dy by dx is taken common here. 1 upon y minus e to the power x plus y is equal to, what's the LCM out here? It is x. So in the numerator, what should you write? X e to the power x plus y minus 1. So it is simplified, right? Or dy by dx. So within bracket, what's the LCM? It is y. 1 minus y e to the power x plus y is equal to e to the power x into e to the power x plus y minus 1 whole divided by x. So now you can get the value for dy by dx. Now let us get the value for dy by dx. So now you can cross multiply it. So y within bracket x e to the power x plus y minus 1 whole divided by x within bracket 1 minus y e to the power x plus y. So this is the final answer. Understood? So you can copy it. Now we'll do the next question. So now we'll do another type of problem, that is 6 number 1. Find dy by dx when x is equal to a within bracket cos t plus log tan t by 2 and y is equal to a sin t. Now we know that this type of function is known as parametric function and the equation is known as parametric equation. So why is it parametric equation now? Because in this case the two variables x and y are expressed in terms of a third variable t, that is known as a parameter t. So that's why this equation is known as parametric equation. Okay, so now let us find out dx by dt first, because here x is expressed in terms of t, here a is constant, right? So here what is the first equation given? X is equal to a within bracket cos t plus log tan t by 2. Now we can differentiate both the sides with respect to t. So write down differentiating both the sides with respect to t. Therefore dx by dt is equal to a within third bracket. Let us write the differentiation of the expression within first bracket within third bracket. Okay, what is the differentiation of cos t? It is minus sin t plus, what is the differentiation of log tan t by 2? Here you should take it as log t. What is the differentiation of log t? 1 by t. But here it is 1 by tan t by 2. Again you have to differentiate the term which is assumed as t with respect to t. That is tan t by 2 was taken as t. Now differentiate tan t by 2. What is it? It is sec square t by 2. Again it was taken as tan t. What is the differentiation of tan t? Sec square t, but it is here sec square t by 2. Again differentiate the term which is assumed as t. Here t by 2 was assumed as t. Again differentiate t by 2 with respect to t. What is it? It is only half, because Half is constant, half comes in the front, half into d by dt of t is always 1, right? So this is the differentiation. Now we have to simplify it, okay? Or this is dx by dt is equal to a within third bracket. It is minus sine t plus, what is 1 by tan t by 2? That is cot t by 2, isn't it? So it is cos t by 2 divided by sine t by 2, right? What is sec square t by 2 into 1 upon cos square t by 2 into half. So here third bracket is closed, right? So here you can cancel this cos t by 2 and square gets cancels, okay? So what is dx by dt? Therefore dx by dt is equal to, that is a within third bracket minus sine t plus 1 upon that is 2 sine t by 2 cos t by 2, right? 2 sine t by 2 cos t by 2. Is it clear to all of you? So now let us simplify it further. Or now you know that 2 sine theta by 2 cos theta by 2 from submultiple angle. So that formula is actually sine theta, isn't it? That is from submultiple angle in trigonometry. You did in class 11. You know that sine theta is equal to 2 sine theta by 2 cos theta by 2. Okay? So our dx by dt is equal to a. So within third bracket, it is minus sine t plus 1 upon. So similarly, what is 2 sine t by 2 cos t by 2? What is the formula? It is sine t. That is, from submultiple angle we have sine theta is equal to 2 sine theta by 2 cos theta by 2. That is the formula, right? So this formula is used here. So again you can simplify it further. Or dx by dt is equal to a within third bracket. What's the LCM? So here the LCM is sine t, right? So sine t into minus sine square t, then write down plus 1. So actually it is 1 minus sine square t is there, isn't it? It is your 1 minus sine square t. What is 1 minus sine square t? That is your cos square t. Or dx by dt is equal to a into, so now in the numerator you can write, so actually it is 1 minus sine square t. What is 1 minus sine square t? It is cos square t divided by sine t. So this is the simplified value of dx by dt. That is, this is your number 1, but that is not the answer because you have to get the value for dy by dx, okay? Now this first function was differentiated and we got dx by dt is equal to a into cos square t divided by sine t, okay? That's the next function. What is the next function out here? It is given y. So again y is equal to a sine t. Now again you have to get the value for dy by dt. So differentiate both the sides with respect to t now. So differentiating both the sides with respect to t. So therefore dy by dt is equal to, here is constant, into what is the differentiation of sine t? It is cos t, right? So mark it number 2. That is d by dt of sine t is always cos t, right? So now what will you do? You have to get the value for dy by dx. That means you have to divide 1 by 2 or 2 by 1? 2 by 1, because dy should be the numerator. That's why you have to divide 2 by 1. So write down dividing 2 by 1. So dividing 2 by 1. So what do we get? So write down left hand side of number 2 in the numerator. That is dy by dt divided by, write down right hand side, left hand side. Write down left hand side of number 1 in the denominator. That is dx by dt is equal to, again you have to write down right hand side of number 2 in the numerator, a cos t divided by, and you have to write down the right hand side of number 1 in the denominator, a into cos square t divided by, it is sin t. So let us simplify it. So we have divided 2 by 1, okay, to get dy by dx. So, or it is dy by dx is equal to b, because here dt gets cancels. So here a gets cancelled, cos t and square gets cancels. So in the denominator it is cos t by sin t. When it goes up in the numerator, it becomes sin t by cos t. It is sin t by cos t, right? So what is the value for dy by dx? That is dy by dx is equal to, what is the answer? What is sin t by cos t? It is tan t. So this is the final answer. Okay, so this question is very, very important. You can revise it at home. You can copy it. So we'll do the next question now. Now we will do the next question, that is find number 3. Find dy by dx when tan y is equal to 2t upon 1 minus t square and sin x is equal to 2t divided by 1 plus t square. So this is also a parametric equation. So here also y and x are expressed in terms of a third variable t, which is a parameter. So this is a parametric equation. So let us simplify first one now. So here given is tan y is equal to 2t divided by 1 minus t square. First of all, you have to get the value for dy by dt, but you cannot differentiate it directly because it will be complicated. Okay, so let us take tan to the right hand side. So y is equal to tan inverse, it is 2t divided by 1 minus t square, right? You know from inverse circular function how is it simplified, or you may use the formula directly also. Don't use the formula directly in this case, okay? Because sometimes you may have to do the trigonometric substitution. So let's do trigonometric substitution here, okay? So what should you put for t so that you can have tan inverse tan 2 theta, that is t is equal to tan theta, right? So let t is equal to tan theta. So let us get the value for theta, because you have to put the value for theta also, that is theta is equal to tan inverse t. So therefore y is equal to tan inverse, within bracket it is 2 tan theta divided by 1 minus tan square theta. Is it clear? So let's simplify it. So therefore y is equal to tan inverse, within bracket, what is the formula for this expression? 2 tan theta divided by 1 minus tan square theta. That is from multiple angles in trigonometry. What is this formula? 2 tan theta upon 1 minus tan square theta, that is tan 2 theta. So it is tan 2 theta, right? So or y is equal, what is tan inverse tan 2 theta? It is 2 theta. Okay, now put the value of theta, then only you can differentiate. So or y is equal to 2 tan inverse t. So actually this tan inverse 2t upon 1 minus t square means it is 2 tan inverse t. So if you know the formula, you can directly write down. Okay. So if you don't know the formula, you can do this trigonometric substitution as we have done in inverse circular function. Now this is the simplified expression. You can differentiate it easily, isn't it? So write down differentiating both the sides. Differentiating both the sides with respect to t, right? Differentiating both the sides with respect to t, what do we get? Dy by dt is equal to 2 into, what is d by dt of tan inverse t? You know the formula, that is 1 upon 1 plus t square. Let us mark it number 1. Similarly, you can simplify the second given function. First you simplify it and then differentiate. Okay? So again sin x is equal to what? Again sin x is equal to 2t upon what is given here? It is given 1 plus t square. So let us get the value for only x. So x is equal to what is sin inverse 2t divided by 1 plus t squared. So here also don't differentiate it directly. Let us simplify it. If you know the formula, you can write on the formula. Otherwise, derive the formula. Okay. So let's do trigonometric substitution. So what should you put for t here? Here also tan theta. So let t is equal to tan theta. Let t is equal to, or you can write tan beta also. So in the first case, we put t is equal to tan theta. Let us put t is equal to tan beta out here. So what is the value for beta? It is tan inverse t, right? So now this x becomes, x is equal to sine inverse within bracket 2 tan beta divided by 1 plus, this is your tan square beta. Now you should know this formula. 2 tan beta upon 1 plus tan square beta, its formula is sine 2 beta, isn't it? This is from multiple angles, or x is equal to, this is sine inverse sine 2 beta, or x is equal to, that is your 2 beta, or x is equal to, what is beta out here? It is tan inverse t. Now we have to put the value for beta also, that is 2 tan inverse t. So that means sine inverse 2t divided by 1 plus t square is also 2 tan inverse t. If you know the formula directly, you can write it. Otherwise, you have to derive this formula. Okay. Now write down differentiating both the sides with respect to t. Differentiating both the sides with respect to t. Okay. So therefore, dx by dt is equal to 2 into, this is also 1 upon 1 plus t square. Let us mark it number 2. So this is your number 2. This is your number 1. This is your number 2. And now you have to find out dy by dx. So what will you do? You have to divide 1 by 2, right? So let us write dividing 1 by 2. Now divide 1 by 2 to get dy by dx. So dividing 1 by 2. So dividing 1 by 2, right? So what do we get? Divide 1 by 2. So write down left hand side of number 1 in the numerator. Dy by dt divided by, write down left hand side of, here we have written left hand side of number 1 in the numerator. Divided by, you should write left hand side of number 2 in the denominator, that is dx by dt, which is equal to, on the right hand side, write down right hand side of number 1 in the numerator, that is 2 into 1 upon 1 plus t square whole divided by, write down right hand side of number 2 in the denominator, that is 2 into 1 upon 1 plus t square, right? So what is the answer now? You can cancel all these here. 2 ones are 2, 2 ones are 2. This also gets cancelled. dt gets cancelled. So what is the value? What dy by dx, which is equal to 1. So this is the final answer. So this is very, very important question. Okay. So you can do it at home. This is your homework. I am giving you the homework. Okay. So find dy by dx. Find dy by dx when it is similar to this problem, right? That is sin x is equal to 2t upon 1 plus t square, and cos y is equal to 1 minus t square divided by 1 plus t square. So similarly, you can do this problem. Okay? So you have to find out dy by dx when sin x is equal to 2t upon 1 plus t square and cos y is equal to 1 minus t square upon 1 plus t square. So this is your homework, right? So let's do the next question now. So now we'll do the next question, that is number 4 of question number 6. Find dy by dx when x is equal to a within bracket 2t plus sine 2t and y is equal to a within bracket 1 minus cos 2t. Okay, so this is also a parametric equation because in this case the two variables x and y are expressed in terms of a third variable t. Okay, so now let us find out dx by dt first. So here given is x is equal to a within bracket 2t plus sine 2t, right? So differentiating both the sides with respect to t. Therefore dx by dt is equal to a within bracket. A is constant here, right? Only you have to differentiate the term within bracket. What is the differentiation of 2t? 2 into d by dt of t, that is 1. 2 ones are 2 plus. Here you should take it as sin t. What is the differentiation of sin t? Cos t, but here it is cos 2t, right? Into, again you have to differentiate the term which is assumed as t. That is 2t was assumed as t. Now differentiate 2t with respect to t, that is only 2, right? Or dx by dt is equal to, here 2 is taken common, 2a within bracket, what is there? 1 plus cos 2t. Let us mark it number 1. Clear? So now next, again y is equal to a into 1 minus cos 2t is given. Y is equal to a within bracket 1 minus cos 2t is given. Now let us differentiate both the sides with respect to t. So differentiating both the sides with respect to what? T, right? So therefore dy by dt is equal to a remains same, and within third bracket for 1 it is 0, minus sign is there. Now we have to differentiate cos 2t with respect to t. First of all you should take it as cos t. What is the differentiation of cos t? Minus sine, here t is 2t, into, again differentiate the term which is assumed as t, that is 2t was assumed as t, so you have to differentiate 2t with respect to t, that is 2 into d by dt of t is always 1, so it is only 2. That is differentiation of 2t with respect to t is differentiation of 2t with respect to t is 2, right? Third bracket is closed. Now simplify it. So dy by dt is equal to a into minus into minus plus, it is 2 sine 2t. Or you can write dy by dt is equal to 2a and this is sine 2t. Let us mark it number 2, right? So let us find out dy by dx now, because you have to get the value for dy by dx. So what will you do? Let us write dividing 2 by 1. Dividing 2 by 1. So what do we get dividing 2 by 1? Write down left hand side of number 2 in the numerator. dy by dt divided by, write down left hand side of number 1 in the denominator. That is dx by dt. Which is equal to, now write down right hand side of number 2 in the numerator, that is 2a sine 2t, 2a sine 2t divided by, write down right hand side of number 1 in the denominator, that is it is 2a and within bracket 1 plus cos 2t, 1 plus cos 2t, right? So let us simplify it. So here 2a gets cancels. So here also dt gets cancels. You will get dy by dx, which is equal to, now next you have to use the formula. This is sine 2 theta, isn't it? You know this formula from multiple angles. Sine 2 theta is equal to 2 sine theta cos theta. You know this formula from multiple angles in trigonometry. Sine 2 theta is 2 sine theta cos theta. And what is 1 plus cos theta? Can you tell me what is 1 plus cos theta? Which is equal to 2 cos square theta. So these are the two formulas that you should use here. Okay. So let us use the formula. What is sine 2t? 2 sine t cos t divided by, what is 1 plus cos 2t? It is 2 cos square t here. So here 2 gets cancels, cos t and square gets cancels. or what is the value for dy by dx? That is dy by dx is equal to what? It is tan d. So this is the answer. So I think I've understood it. This is also very, very important question. So you can copy it. Now I'll give you the homework, right? So now these are your homework. Okay, you can do it at home. First, you revise all the problems that we did today, and it will be easier for you to do this homework. Okay, so first you have to revise all the problems that we did today. Okay, then you can do this problem. So your homework is find dy by dx when 5 number 2 x to the power y is equal to y to the power x. You have to take log on both the sides and then differentiate. Number 9, y to the power y is equal to sin x. Here also you take log on both the sides and then differentiate it. Okay, because y to the power y, both base and the powers are the variables here. You cannot differentiate it directly, so take log on both the sides to differentiate it. That is to get the value for dy by dx. Okay. Now for 6 number 2, it is the parametric equation given. That is x is equal to a into t minus sin t, y is equal to a within bracket 1 minus cos t. So these x and y are expressed in terms of a third variable t. So here a is a constant, here t is a parameter. So this is a parametric equation. First you get the value for dy by dx, as we have done in problem number 6.4. In 6.4 also we did it, isn't it? It is same as problem number 6 number 4. First find out dy by dx, then get the value for dy by dx, then you have to put t is equal to pi by 2 in instead of t. So first of all, you have to find out the value for dy by dx from here. And in that value of dy by dx, you will get the term containing t. And you put t is equal to pi by 2, you will get the answer. So these are your homework. Okay? So this much is for today, right?